Welcome to NCIX Tech Tips. For those of you who have been watching this channel for a while, you will be no stranger to our overclocking guides that tend to come out along with any new platform. So the new platform we have today is the X79 platform from Intel, featuring their all-new Sandy Bridge E or Core i7 second generation processors on the LGA 2011 socket. So yes, I'm going to reach around here. We've got this cooler here which fits on the new LGA 2011 socket, which is bigger, has more pins, that is exactly 2011 pins, and is more scalable in the future with upcoming technologies such as 8-core processors and current technologies which didn't exist until this socket launched, like 4-channel memory. So yes, we have a quad-channel memory controller which supports up to 8 DIMMs on a consumer level board, which means you can pretty much build a pretty wicked workstation at a relatively low cost compared to what we've seen in the past. So we're going to show you guys how to get the most out of this exciting new platform from Intel. The first thing I want to cover is the hardware you guys are going to need before you can start on any overclocking endeavor. So that starts with the platform. This is the LGA 2011 platform, so you can see here to represent the 2011 platform, I have a stock Intel heatsink. Mind you, box processors from Intel will not necessarily include stock heatsinks, so that is more just as a prop than anything else, but that is representing the LGA 2011 CPU that is on my test bench here, and I hope you can get enough of an angle at it. You will also need an LGA 2011 motherboard. So in this case, we've gone with the MSI X79A GD65 8D. The 8D means it supports up to 8 DIMMs. So we don't have 8 DIMMs on it right now. We've got 4 DIMMs of Kingston HyperX DDR3 1600 megahertz memory. Now on this platform, you're not going to need crazy high bandwidth, high frequency memory for a couple of reasons. Number one is that this is using the Sandy Bridge architecture, which means that we've got high efficiency built in from Intel's side for making use of the bandwidth that's available. The other thing is that by adding an additional channel, remember, these 4 DIMMs are all running on 4 separate channels, so that means we've got a theoretical 33% increase in bandwidth over LGA 1366 just by adding that extra DIMM alone. So we'll need a quad channel memory kit, we'll need a 2011 processor, and this guide is covering multiplier overclocking, so we're going to need a K-series or an Extreme Edition processor, and finally we will need an LGA 2011 motherboard as well as a compatible cooler. More on cooling in a moment. Now, having all the hardware is one thing, but you're also going to need the right accessories to go with it. So in this case, I didn't think it made a whole lot of sense to take an Extreme Edition processor. In this case, we have the 3960X 6-core 12-thread Extreme Edition processor. I didn't think it made a whole lot of sense to throw this guy on it. This is a stock fan with a 92 mil, or stock heatsink with a 92 mil fan. Yeah, that's just not going to cut it. It's not extreme enough. So we decided to go with the Corsair H100, which, by the way, every H100 is out of the box ready for LGA 2011. So the H100 gives us 2 full 120 millimeter fans worth of surface area to dissipate heat. And the way we've configured it here, this is all about cooling, is blowing the air onto the motherboard rather than pulling it away. So I'm going to go ahead and turn this around and I'll show you guys why I did that. On LGA 2011, because there are so many memory DIMMs and we still need to make room for all those other things like video card slots and I/O ports, well, there's a lot less room for the power delivery, which is a bit of a struggle for the motherboard guys because this socket is capable of pulling over 200 watts from the power supply. So that means that not only do you need a board that has a very robust PWM with a nice big heatsink, but you're also going to want to give it some active airflow. So that means that if you have a case that has top fans, you probably want to turn those around and blow air down to your CPU socket, which is going to cool your memory modules as well, and then use your rear fan in your case as an exhaust to pull that hot air back out of the case immediately to make sure you're cooling your power design. Now, speaking of power, before you overclock a CPU that's going to require 200 watts on its own, you're going to want to make sure you have a decent power supply. So we've gone with the OCZ ZX series, fully modular, 80 plus gold power supply. This is the 1250 watt version, which is Probably a little bit overkill for the machine we have here with only a single GTX 580, 4 DIMMs of memory, the Extreme Edition, and then an SSD, which is focused on power efficiency, but is also very fast. So you could probably get away with a ZX 850 or something along those lines, but this would be a great choice if you decided to go for a Quad SLI GTX 590 setup to go with your Extreme Edition. So let's talk about the different options that you have for a 2011 processor now. So there's the 3960X, which is an Extreme Edition processor, 6 cores, 12 threads, 15 megs of cache. I mean, remember, 15 or 16 megs used to be like system memory amounts not that long ago, so it's kind of amazing to see how far we've come. So there's that option, and then you also have the 3930K. Now the K, like the K would indicate, is also, like an Extreme Edition, multiplier unlocked. It does have 6 threads, or rather 6 cores and 12 threads, and it is only 100 megahertz slower than the 3960X at its highest turbo speeds as well as at its base speeds. So they're 3.2 gigahertz and 3.3 gigahertz for the base speeds, and then they are 3.8 gigahertz and 3.9 gigahertz for the max turbo speeds. So given that it's about half the price, I think most of you guys are going to be using K-series chips, but bear in mind that the overclocking procedure we're showing you today is the same whether you're using an Extreme Edition or a non-Extreme Edition. Now, not yet, but coming later, there will also be non-unlocked chips, which you will have to overclock using the base clock, like we did on LGA 1366. But wait for those chips to be released before I show you guys how to overclock those ones. Here we are in the Click BIOS 2 UEFI BIOS that comes with the X79A GD65 8D. There's a non-8D version. And I just want to show you guys how we're going to navigate this to do what is actually a very simple overclocking procedure. So all we have to do is go into the overclocking settings, and we can use the keyboard or we can use the mouse to navigate around in here. It's totally up to the individual user. Personally, I love the way they've laid out these side menus, and I find it actually still faster to use the keyboard than the mouse and more efficient than the previous BIOS implementations that we used to see in the past, the non-UEFI ones. So in terms of overclocking, we're not doing base clock today. We actually don't need to change much in terms of voltages, so what all do we have to do? So we're going to adjust the base clock ratio. Nope, we won't be touching that. We won't need the, oh yes, we will need the CPU ratio. So you can see the CPU ratio is at auto, which is 33, giving us 3.3 gigahertz. So we're going to go ahead, and we've already tested this, so you're going to need to try one setting and then go until it's unstable, and then bump up your voltage, and then try another setting, then go until it's unstable, keep going up, and then you'll need to bump up your voltage once it's unstable. But we found that the sweet spot for us, and you can definitely try these settings, was 46 for our multiplier, so 4.6 gigahertz. We're leaving on speed step as well as turbo boost 2, because those are what allow us to change the CPU ratio on the MSI board anyway. We're going to turn off OC Genie just because we won't be needing that. The Direct OC button allows you to adjust the base clock. Since we're not doing base clock overclocking, we will not need that either. DRAM frequency, we're just going to leave at 1600 megahertz without an extreme memory profile, because memory performance really doesn't impact the overall system performance very much on this particular platform. DRAM timing mode, we're going to leave it linked. So that is to say that we are using the same timings on all of our channels across the board. And those auto timings are exactly what it should be reading from the memory. 99924 with the command rate of 1T, so that is just perfect. VDROOP control, we're not going to change that. Intel does leave the VDROOP spec into these boards for a reason. That is an Intel spec. Sometimes by adjusting VDROOP control, so you can see you can adjust it higher levels. Higher levels mean less fluctuation of the vCore under load. VDROOP at auto means that the voltage will actually dip a little bit when you go under load, reducing the overall heat output of the CPU. So you can get a little bit more stability by turning that VDROOP control up higher, but Intel's got it there. We didn't need to turn it up in order to reach 4.6 gigahertz, and that's a pretty good overclock, so we're going to stick with it. CPU core voltage. The core voltage that we went with was 1.55, and that is pretty much the maximum that I'd recommend for a pre-done water cooling setup like this. You might be able to go a little bit higher, like 1.6 if you're using a custom water cooling setup, and maybe even higher if you're using exotic cooling. But I would stick in that sort of 1.55 range, 1.45 to 1.5 for air cooling. You are going to be cooling limited at that point. You're going to find out that when we're done our overclock here, we're actually running at 90 degrees with a very intense load, Prime 95 small FFT. Did I say 100 degrees? I meant 90 degrees. Oh, I said 90 degrees. Oh, good. Cameraman was giving me a look. So it does stay stable at that setting, so it's no big deal. And that's a very unrealistic load for the system, so the CPU is never going to get that hot. But so you'll see that 1.55 is pretty much all that the Corsair H100 can handle, which is where I was going with that very long story. Now on past platforms, system agent voltage or alternate voltages other than the CPU V-core haven't necessarily mattered, but on this particular platform, the system agent or SA voltage does make a difference. So we've got it bumped up to 1.3 volts, but anything up to about 1.4 to 1.45 volts is probably safe with a water cooling solution like what we're using, and anywhere from about 1.35 to 1.4 is probably just fine for air as well, but we didn't need that much in order to achieve our 4.6 gigahertz overclock. Now moving down, there's not much else that we need to adjust here. Just going to go down to the very bottom where we see the CPU features. Now it's a little bit finicky in terms of what you can enable and disable in order to keep the overclocking working, because to overclock this platform we are relying on certain features such as I mentioned before, the speed step as well as the turbo boost features. So here we're going to go ahead and we are going to have our custom power technology set to custom, which is what we did on the previous screen. We've also got C1E support enabled, C-states enabled, and then set to auto. Another thing I have adjusted here is I've set the short duration power limit to 250 watts and the long duration power limit to 200 watts. I'm going to press F10, save the configuration and reset. We're going to boot up into Windows, and then we will test our overclock. Now the reason I set those power limits to such high values is because, need I remind you, this CPU is capable of sucking at these kinds of speeds up to 200 watts through the socket, so you got to be prepared for that. You don't want a safety protection mechanism built into the motherboard to limit your overclock, because that would be a shame. Now in many instances it is considered better, from the purist in me, to turn off things like speed step, which is reducing the voltage and reducing the clock speed of the CPU at idle and then ramping it back up under load, and turning off anything like that that adjusts, plays around with the frequencies or voltages, and just going for a pure flat clock speed. But you can see right here, now that we're booted into Windows, I am running at a whopping 1.2 gigahertz on my CPU with a very low idle temperature of only 30 degrees Celsius, which is outstanding. Because we've left all those things on and we've gone with a more conservative overclock, yes, you can achieve probably more along the lines of 4.7 to 5 gigahertz with a cooler like this with this CPU. We've gone with a more conservative overclock in order to have the best overall experience. So you can see once I fire up my Prime 95 small FFT, which is what we're going to use, 12 full threads, which is going to completely consume all of the resources that the CPU has to offer. As soon as we do that, the CPU switches to 4.6 gigahertz, which is the overclock that we are covering today. Now, the last step in any overclocking endeavor is always stability testing. So in this case, we are going to be using Prime 95 small FFTs, or we have been using Prime 95 small FFTs, and I would recommend, for the most assurance, peace of mind that it's not going to be unstable in any way, that you run it for at least 12 to even 24 or even 48 hours, depending on what you're trying to achieve in terms of stability. Now you can see here that our CPU is running at about 90 degrees. Now in real benchmarks, our CPU never goes nearly that high, but this is what I would consider to be an absolute worst case scenario. However, and we're limited in terms of our filming schedule and how long we can leave it running. Check this out. We did have it running stable even at that temperature for 3 hours and 14 minutes. So I would say that with 99% confidence, if it runs small FFT for 3 hours, we can call our overclock stable. So we did achieve an overclock of 4.6 gigahertz, which is more than 1 gigahertz over the stock speed on this CPU. And that is with all 6 cores and all 12 threads running and giving us some serious performance improvements over the stock CPU. So thank you for checking out our overclocking guide for the 2011 platform. Thanks to Intel and MSI, who both generously provided us, and Kingston, who all generously provided us with this hardware so we could bring you this overclocking guide right on launch day. Don't forget to subscribe to NCIX Tech Tips for more great reviews, tutorials, and other computer videos.